So it looks like I made a bit of a mistake in my previous video when talking about the longitudinal transmission line. Now, what I said in the video was that the magnetic rises towards the load and that the dielectric rises or basically declines towards the load, and that turns out to be incorrect. So first I'm going to show you the section of the video where Eric Dollard is talking about this, and then I will show you my correction.
Line up so you can see how it's constructed. You can be more careful now because it's much more intense, transverse and longitudinal mode. Okay, we'll do our sweep here, and you can see the resonance is extremely sharp on this. I just barely move the dial and it goes out. And the activity is so high that now it'll even light a fluorescent lamp with the same amount of power. So as you can see, I only need one wire at this point, where before I had to connect up in conventional electric circuit fashion. And again, remind you, this is the same amount of power. So we can see the oscillations are much more rapid, much more intense. Now let's study this like we did before. Let's start by seeing what our magnetism looks like. So we'll start down at the bottom here. We don't get too much indication. And it goes up there fairly well. It's quite intense there. And here I don't even dare bring the thing up, or I'll burn the meter out. So we see, in contradistinction to before, the magnetism is rising towards the open circuit, something that doesn't normally occur with conventional electric waves. Now we'll do the dielectric part. And of course you're probably seeing interference in the TV screen, and of course that's, as you've seen in the other videos, is characteristic when we start to deal with longitudinal waves, as they propagate quite well through space, or in this case we might say counter space. And we can see the dielectricity drops right off. Now for comparison, I'll put the neon bulb right across the line. And you can see it's just brilliant. I don't dare keep it there. It'll be gone in a second. And we get quite a spark off the end of the thing too. So for the same amount of power, this thing is operating at a much more rapid rate, much higher efficiency, and we can do a lot more things with it.
So clearly what Eric Dollard is saying is that the magnetic component rises towards the load and the dielectric rises towards the load. So in contrast to the transverse transmission line, where the dielectric rises towards the load and the magnetic declines towards the load, and that's the terminology he's using, it turns out that both the magnetic and the dielectric increase towards the load. And so I just wanted to make that perfectly clear because I think it's important to be accurate when I'm making these videos. Now I just want to point out that obviously this is not my area of expertise. I'm not making these videos because I think that I'm an expert in this field. I'm making these videos because when I find something that's interesting to me, I want to pass it along to you. So my hope is that this information will help you all out there try to understand these concepts. I am still trying to understand these concepts, and I really appreciate the feedback I'm getting from you, and including and especially when I make a mistake. Okay, so that's all I'm going to say for now. Thank you to all of you that pointed out the problem, and I'm happy to make the correction, and I think it's really important to get this right. So thank you all, and I hope you're having a great day.